and welcome to TerseScript. Just real quick about me, I'm Mike Hand, here I am. About 6 months ago now, I joined a startup in Columbus called Rove. Our goal is to turn every renter into an owner. Right now we're working to make it possible for renters to own a stake in the apartment building that they live in through a product we call rentership. I think it's really cool. You can check that out at rove.com if you're interested. So that's what I'm working on now. As far as background, I've worked in a number of environments: defense contracting, small privately owned, consulting, all kinds of stuff. I primarily have experience in Java, with some other odds and ends like C++ and JavaScript. But I have a strong interest in what makes languages tick. Software languages, human languages, languages of all kinds. And that's a lot of what drove the creation of this talk. I say enough of the low-hanging fruit of how weird and clumsy JavaScript is. Let's really dig in and have some fun with it. So JavaScript, I think, is exciting since it's a language where everything is possible and almost nothing is safe. So for this presentation, I want to explore some of the inner workings of JavaScript better in hopefully an entertaining way. The possibilities are endless, but so are the pitfalls. So let's have some fun with it. So the goal, I think, is to write hello world in JavaScript. Let's see if we can accomplish that. And we can. Great, hello world in JavaScript. There it is. But they gave me a full hour. So let's see if we can jazz this up, make it a little bit more interesting. Okay, let's see if we can write hello world using only 6 characters. That'll be the brackets, parens, bang, and plus. It's going to get interesting, it's going to get weird, and I think we're going to have some fun. So the first thing that we need to do is establish some building blocks, some foundational things that we can build on. Let's just start with the brackets. So we can do some very simple things with brackets, like maybe make an empty array. Bracket, bracket, that's an array, very simple. But if we use a couple more characters, we can make some seemingly weird things happen. Empty array plus empty array, empty string. Okay. Plus empty array, we get a 0. Not empty array, we get a false. So we can do 3 different operations on only an empty array. We're not passing it into a method. We're not calling some array.prototype method. These are just basic operations. And we get back an empty string, a 0, or the Boolean false. So the first building block we need is to understand that everything in JavaScript, every possible thing, can be represented as one of these 3 primitive data types, either a Boolean, a number, or a string. So let's test some of these and wrestle with this for a little bit. Let's throw some things into the constructors for a Boolean, a number, or a string, because there are constructors for these. So let's make a Boolean out of an empty array. That yields true. Let's make a number out of an empty array. We're going to get back 0. And let's make a string out of an empty array. And we're going to get back an empty string. We can also make a number out of the Boolean literal true. We can make a string out of the Boolean literal true. We get back number 1 or the string representation of true. We can make a Boolean out of string hello, and that's true. And we can make a number out of string hello. Then we get not a number. Fair enough, although not a number is a number. We can make a Boolean out of the number 42, or we can make a string out of the number 42. Let's try a couple more special things. We know that there's a concept of infinity in Java. Let's see, can we make a string out of infinity? Yes, we can, and we get back the string infinity. we can make a Boolean out of +0, which is false, -0, which is false, or just plain 0, which is false. We can make a Boolean out of a negative number, which is true. We can also make a Boolean out of a function. So let's make up this function a, b, and we're going to return a plus b, lovely little function there. And that function, as a Boolean, evaluates to true. We can also take a string representation of that function, which will be the characters that represent that function as text. So this is all just built into the language, and it's all defined in the spec. If we bring up the spec, which I happen to have here, and we check section 7.1.2, or sorry, 7.1.12, and if you bring up a spec, it might be different. This spec is just one that I'm a little bit more familiar with, but I think it's a little bit older. So some of the tables or sections might have been moved around a little bit. But we can see that if we want to turn something into a string, this kind of like internal toString method or procedure will get called. And we can see what the rules are. So undefined and null, they get turned into string undefined and string null. That makes sense. A Boolean, if the argument's true, it's going to be string true. If it evaluates to false, string false. Again, that makes enough sense. For numbers, we have to punt out to this number to string routine. And that's right below here. And you can see, again, it's all laid out. It's all defined in the spec. So the first thing we do is if it happens to be not a number, easy. We can cut to the chase, NaN. If it's plus or minus 0, we can return 0. If it's less than 0, we return the string concatenation of a minus symbol or a dash, and then we call number to string, turning that number into a positive. Now, when your spec starts using recursion, you know that you're having fun. Okay, next we cover infinity, and then things get a little bit involved. You know, let n and k and s be integers such that blah, blah, blah. It's a whole thing, and it looks complicated, and it is, but the point is it's consistent and repeatable. If you're following the spec, you're getting the same answer every time, whether it's Chrome, Firefox, Node.js, whatever Microsoft's putting out if they feel like playing ball. You can see in step 9, for instance, how we get some of the scientific notation formats for how certain numbers might be represented as strings. None of it's guesswork. The spec defines all of that. So, okay, let's go back to the main table here. Strings don't get converted. They already are a string, so it just gets returned. That makes sense. Objects will be converted in two steps. We're going to convert it to a primitive, and then we're going to take that primitive and convert that to a string using these rules. So if the primitive happens to not be a string, we can convert that primitive to a string with one of these other steps. Now remember how I said everything can be represented as a Boolean or a string or a number? That's not true. There's a newer concept called a symbol. To be honest, I don't know a lot about these symbols, but they actually don't play nice with all of these primitives because JavaScript is awesome. And if you try to convert a symbol to a string, you'll get a type error exception. So your only options here are that you're going to end up with a string, a number, or a type error exception. And if you get a string or a number, we know how to convert those to a string. Now let's take a look at 7.1.3. Went the wrong way here. To number. So here are the rules about converting something to a number. And it's about what you'd expect. Undefined, not a number. Null, though, is not a number. It's 0, a positive 0. A Boolean is either going to be a 1 if the Boolean's true, or a plus 0 if the Boolean's false. Number's already a number. We don't need to convert that. And then we get to string. So strings are a little bit special. Basically, the string has to follow all of these specific rules for how it's formatted. If it does, then it can be converted into a number. If it doesn't, then we're just going to give up. So, but there are some interesting aspects here. For instance, white space is allowable. So we can have number space, 42. It likes to insert periods on me when I press the spacebar too fast, and that's fine. Only white space is also allowable, and that'll just get trimmed and go to 0. Only a plus or a minus is not, but plus or minus 0 is. Plus a lot of zeros or minus a lot of zeros is also okay. All of that's fine. But basically, if it doesn't follow anything else, it's just going to be not a number. So a number for any other string, be it hello or a simple mistake like with 2 dots, anything like that, just not a number. Couldn't do it. Symbols, again, they don't play well with being converted into numbers. And then objects, it's like with strings. We're going to convert it to a primitive, and then we're going to call toNumber. So in case the primitive that it gets converted to is a string, then we'll follow the rules here to convert that string into a number. And then there's one more, toBoolean, the simplest of the bunch. If it's undefined or null, we get false. Boolean is whatever the Boolean is. Number, and this is where people can kind of guess wrong sometimes, plus or minus 0, not a number. Those would be false. Any other number is true. So as long as it has magnitude at all, it's true. That's why the negative numbers will be true. Sometimes people think that the negative numbers might evaluate to false. String, as long as the string has length, it'll be true. If the string does not have length, if it's an empty string, then it'll be false. So, some people might think, well, null, nope, that's fine. It's true. String 0, that's also true because they have length. We don't care what's in them. As long as they have length, they're true. Here's where symbol throws us a curveball. Any symbol, true. As well as any object, true. Doesn't matter what's in it. Objects, symbols, they're just true. Okay, great. So toString, toNumber, toBoolean. Why did we waste time on this? Well, since everything, except symbols, in JavaScript land can be converted to any of the 3 of these primitives on demand, we're going to abuse that. But first, we need to know how to coerce types into these 3 primitives. So a quick aside on type coercion. JavaScript is an extremely permissive language. It's dynamically typed, meaning the types of variables are not fixed. They can change throughout the lifetime of the program. It's weakly typed, which means types don't have to be compatible to be used in an operation together. It also uses duck typing, which is a play off. If it walks like a duck and talks like a duck, it must be a duck. In terms of type systems, this means you can do things like attempt to call a method on anything without knowing its type. If it has that method, it will just do it. So this all adds up to an extremely permissive type system. Again, I'll repeat, just about anything is possible, and almost nothing is safe. But to make this all work, the JavaScript runtime has to do something to make otherwise incompatible types compatible. This is where type coercion comes in. When 2 types are being used in an operation that doesn't necessarily make sense, JavaScript doesn't have a problem with that. It just converts at least one of them to a type that is valid for that operation automatically. Some languages allow this but require it to be explicitly performed by the programmer. This is called casting. And some languages just assume that what you want is crazy and they're just going to allow it. Either way. So let's take a look at some type coercion in action. Boolean is the most obvious, and it's the simplest. We can coerce types to a Boolean representation just by putting a bang in front of it. So we can say like bang hello. So that's converting the string hello to a Boolean, and we're going to get false. Now keep in mind that if we put it into the constructor, we would get true. But the bang, not only does it coerce it to a Boolean, it actually acts on it and flips it to a false. So if we wanted the true value, we'd have to say bang, bang, true. Bang, bang, hello, and we get back true. Okay, so keep that in mind. These are all reversed. We can put bang in front of that empty array. We get false. Put bang in front of the number 42, or in front of an empty object. You got yourself a Boolean. Okay. Number is similarly easy. You just put a plus in front of it. This is the unary operator. So we can go along with the same examples. Plus hello, not a number. We couldn't convert that to a number that was sensible. But we can do, our plus string 42 and get back 42. We can do plus on the empty array, and we're going to get back a number 0, plus a Boolean literal, and we get back a number. And we can do plus on that empty object, and that object is not a number. Okay. String is a little bit more involved, and it depends more on context. If we use the plus operator with an empty array on the left-hand side, JavaScript is going to treat this as string concatenation. And we'll talk about that in a moment. But for now, let's show an example. Okay, so an empty array plus empty array, and we're going to get back an empty string. Empty array plus a number, we're going to get back a string representing that number, and the same with the Boolean literal, and the same with the empty object. The string representation of that object is it's an object called object. Now the reason for this can be found again in the spec. And in this version of the spec, it's in 12.8.3, the addition operator. So the addition operator, as it says, performs string concatenation or numeric addition. That's a note right up front. It's letting you know. This begs the question a bit as to why it's called the addition operator instead of something a little more generic, but that's about the simplest of JavaScript's lovable quirks. So all these rules are followed here to determine, by context, which of the two possible operations will be performed, string concatenation or numeric addition. You can see in step 7, we actually check for string concatenation first. All this is basically just saying, what's the type of the left side and the right side? And then we're going to say, hey, if either the left or the right, if either of them are a string, then we're going to do string concatenation. That's right here, 7C. Return the string concatenation result of the left side and the right side. So the so-called addition operator actually defaults to string concatenation. And you'll note that they actually list it first up here. We're going to perform either string concatenation or, if we have to, numeric addition. Again, it doesn't have to make sense, but it's strictly laid out. It's repeatable. Okay, and then if that fails, then we'll go ahead and we'll add them two together and we'll get numeric addition. But most of the time, we're likely going to end up with any two random types doing string concatenation. Okay, so we're ready to do some type coercion. We're ready to abuse JavaScript. But obviously, we're still nowhere near close to being able to write hello world with only these 6 characters. We've got kind of some conceptual building blocks, but we're still learning the tool set. So let's start from the bottom up and let's work on replacing Booleans, because we can't go around using true and false. None of those characters are allowed. Reminder, we're only going to be using these 6 characters. So we need to know how to represent true and false using only these 6 characters. So thankfully, we've actually already done this one. We know how to get false. That's just bang array. And once we have false, we know how to get true. We just take that and then we flip it, right? Okay, so we've got bang array false, bang bang array true. This is actually fairly eloquent. It's about the same number of characters for true, and it's actually 2 less characters for false. It's quite a time saver. I don't know why everyone doesn't do this. Okay, so let's try something a little bit harder. We've got all the Boolean literals because there are only 2. Now we need to get some numbers. Now we did before come up with 0, which is just plus array, the unary operator applied to an empty array. We're going to get back 0. Now what would really be helpful though is if we had a number with some magnitude, because we can't really do much with 0, right? We can add 0 to 0, but we're just going to get 0. We're not going to get very far that way. There's nothing to build off here. Now 1, that would be really useful. The cool thing is now we can use Booleans to help us. Now that we have our Boolean building blocks, we can use that to help us generate numbers. And we know that plus true gets coerced into a 1. And we know how to make true. That's bang bang empty array. So now instead of plus true, we can take our representation of true, coerce that into a number, we get 1. Now this is great. This is a really foundational building block, because as long as we can create a number with some value, with some magnitude, we could simply add it together as many times as we need to get a number with increasingly greater magnitude. So we can take this and we can add another 1 to it, and we get 2. So how are we going to get higher magnitude numbers? We're just going to keep stringing these together, 1 plus 1 plus 1 plus 1 plus 1. Well, that'll scale reasonably well through, say, 9. But after that, we have the building blocks for any number that we need with the help of strings. So, for example, let's take our number 2, and let's put parentheses around it to kind of mark that as a unit. And let's coerce that into a string. Okay, so now we have string 2. And I'm actually going to I'll put that inside the parentheses. Let's mark that as a unit. And now let's add a 1 to it. So we have our 1 right there. And now we have string 21. Nice and tidy. Because once the 2 is a string, anything that we use the addition operator on, we're going to also result in a string. So we don't have to use that again. So string 21, that's great. We're building pretty quickly here. Let's add a 0 to the end to scale this a little bit. So we say add a 0, boom, 210. So we didn't have to string 1 plus 1 plus 1 plus 1 plus 1 plus 1 210 times. We can use the power of strings to just get any digit, 0 through 9, coerce that into a string, and concatenate them together. So this is going to be a much quicker way of doing this. So we've got 210 as a string, but we still want it as a number, right? So let's consider this as like one logical group and we can just coerce that back into a number. Very nice. I don't know why JavaScript isn't taught this way. This seems like a lot more fun to me personally. So we've got Booleans and numbers. Any Boolean we want, easy, true, false. Any number that we want, any number at all. Now, let's talk about characters. We can only do so much with numbers alone. But now, just as we used the Booleans to help us generate numbers, we can use numbers to help us generate characters. Because what's a string but an array of characters? And arrays can be indexed with numbers. So let's again start simple and work our way up. Let's say that we have true. I'll put this back up at the top. Our Boolean literal true. Well, we know how to coerce that into an array. We have true, and then we know how to take true and use that with only our special 6 characters. Now we've got this string of true, completely legal. Let's consider this as a logical unit, and then let's get the 0th element on that. And we're going to get back the string t. Good. And not that complicated. It's a sliding scale. So let's start replacing these characters with our special 6. How are we going to replace 0? Well, we know that we can just use a plus empty array, and we're going to get back string t. So that's how we can start to get characters. Basically, if we can figure out how to make a string representation of something, we can index into that string at the proper place and pull out the individual character that we want. So another easy one is the f from false, and that's actually 1 character less, because instead of making true here, we can just make false, and now we have our f. And then obviously we could go through true and false and index into them at the 1st and 2nd and 3rd and 4th places to get additional characters. And now we can really see how this game is played. Basically, this becomes, how do we generate strings with the necessary characters? True and false are obviously super easy, and they'll give us 8 characters total. A, E, F, L, R, S, T, U. Sounds like Wheel of Fortune. And now that's something, but we've obviously got quite a ways to go. So let's see, what other low-hanging fruit is there? How about undefined? Undefined is pretty easy to generate. For instance, we can take an array and try to access that array. And we're going to get back, autocomplete getting me here, a syntax error. But we didn't really try hard enough here. So let's ask for some element on that array, like maybe the 0th element. Now, boom, we've got undefined, and we can easily coerce that into a string by adding an empty array to it. Okay, but we still can't use 0. And actually, I guess I went a little bit quickly. We haven't explained exactly why this is true. We have an empty array, but we're asking for the 0th element on that empty array. That 0th element doesn't exist, and so we get back undefined. Get that, and we turn it into a string. We coerce it into a string plus empty array, and then we get back string undefined. Okay, now we need to do it without using the 0. Well, there's a couple ways we can do that. We can do plus empty array in there, that's 0, or we can use another loophole in Java, which is that you can also pass in a string, and it will try to get that particular attribute on that object. And we know how to easily get a string. We can get an empty string, but with just an empty array. That's going to coerce into a string. So now we're asking for Basically, this is the same as quote, quote, but with using only our special 6. So with 1, 2, 3, 4, 5, 6, 7, 8 brackets and a plus sign, we can generate undefined. Okay, so that's great. But we already actually had several of these characters. Some new ones, though. So now we can add DIN. So now our running total is A, D, E, F, I, L, N, R, S, T, U. And no, that's not off the top of my head. I have them written down in my notes. So the theory of diminishing returns here, right? Well, let's show one more quick example. From undefined, we can easily get not a number by throwing a plus on the front. So this is not a number. Undefined coerced into a number is not a number. And then we can coerce that into a string with plus empty array, and we get NaN. Now we can see we're getting some capitals into the mix. So just to show you, yes, basically as long as you can find the right string representation, you can get any character that you want. Yes, they all are possible. We'll talk about that in a little bit. Let's put a little bit of a pin in that. Right now, let's just see if we can write out a simple word, like maybe find. So let's, for instance, take undefined. Let's put some parentheses around this, consider this as a group, and let's index into it. So at index 4, we'll find F. At index 5, we'll find I. At index 6, we'll find N. And at index 8, we'll find D. So now let's string these all together, and let's see if we can spell out this word. So I'm going to copy that, and then I'm going to start pasting this in and update the index. So F-I-N and D. So now all of that we can spell find. Now, the numbers are still in there, and I'm going to kind of leave that as an exercise for the reader, because it's just going to start to get kind of cumbersome. That's going to be an increasingly growing theme here. But we've already proved that we could do that, right? We just need to string together 1 plus 1 plus 1 plus 1, since all of these are lower than 9, and we can get there. But for now, hopefully this will suffice for you. Now, we could continue to go on from here and fill in all the gaps in our letters list, but I'm going to settle with find for now and kind of leave that as a teaser. Okay, so still though, let's back up for a moment. Let's say, does this actually do us any good? Let's say that we get all the characters that we need. If the idea is that we're going to find all the characters and we're going to concatenate them together and build a string, what's our best case scenario? It's something like alert hello world as a string, which that's just going to print out hello string to the console. That's not really a hello world. Cool way to generate a string, but so what? Well, there's one more piece to this. As long as a string represents valid JavaScript code, we can evaluate it and execute it. So one way to do that is by throwing it into an eval function. So let's evaluate the string of characters. And since it's valid JavaScript code, it evaluates and we get our hello world. Okay, great. So we can build up our code character by character as a string and then eval it. Well, except that's still cheating. It's really close, but it's still cheating because we're using EVAL, and all of those are banned characters. Well, I do not know of a way to programmatically generate an eval function that executes, but we can do this the long way. And at this point, why not? So let's take another quick step back and let's revisit our humble array. Get rid of this. Okay, our array. Arrays have a number of built-in methods available. Arrays are, in fact, actually just objects. So we could pick any of these methods here that come up in the autocomplete, and they'd all work the same for the sake of where we're going. But a couple do stick out to me. Map and pop, because they only have 3 characters. They're nice and short. And pop has 2 P's in it, so that makes it even a little bit simpler. There's really only 2 characters that we need to find there. But as we've briefly seen, building up words character by character, brevity counts. And find is only 1 character longer, but we've already seen how to spell out find. Okay, so let's just plop in find. Okay, why are we talking about array.find though? Valid question. And by the way, if you know where I'm going with this, you know JavaScript quite well. So array.find, and any method will do. It's just that we can get an array with 2 keystrokes, and we know how to get find without too much fuss. We're going to start pulling this together conceptually. So when we ask for array.find, now we're not executing that method. We're just saying, give me a handle to it, right? Point to it. It returns the find method. And what are methods? What are functions in JavaScript? They're objects. And what do objects have? That's right, they have constructors. So array.find returned a reference to the array.find method. But array.find.constructor will return what? Well, since it's a function, it's going to return a function constructor. And what do constructors do? They construct things. So a function constructor constructs functions. So if we pass in to this function constructor something like alert hello world, we're going to get back hello world evaluated. It executes because everything is possible and nothing is safe. Okay, so hang tight with me because we're so close. The code that we build up is not going to be code. It's going to be a string, right? So let's replace this with a string. Give me a moment because I need to switch my string types here. And if we throw in a string and then we run that same code, we're going to get back a reference to an anonymous function that has our code in it, alert hello world. Okay, so it's not too bad. We can do something with this, but it needs a little bit more juice. It needs a little bit more work. So if we get back this anonymous function, how are we going to execute it? Well, that's actually easy. We can just throw in another pair of parens and ask it to execute itself. So this time, instead of returning to us a handle to an anonymous function with the hello world alert in it, we're going to actually execute that alert hello world and get our hello world. Now you shouldn't really do this, but it is possible. So we still have a lot of characters in here that are illegal. In fact, all of this, .find, .constructor, all of that is illegal. We're still using a ton of banned characters. But we have proven that we can get any character that we need. I don't want to say easily, but if we put in the effort, we can get any character that we need. So, great. We've done it. We're all the way there. I'll leave almost all of this as an exercise for the reader, but let's take this last step and let's show that we can actually do this with strings. So instead of the dot notation, we're actually going to have to change this and use a different form. And we can do the index notation, and this is going to work just the same because JavaScript is weird. And now that we've proven that we can call these with just strings, let's go back in our history, and here's find as a string, and let's replace find with our special 6 representation, okay? F-I-N-D, and we're going to execute this, and it still works. So we can see at this point, really the only thing left to do is find strings that we can index out all of these other characters from, and we already have a number of them, even with just what we've done so far, and then we can execute hello world using only those 6 characters. There's still a decent bit of work left to do. The numbers need replaced, and all of those other characters need to be figured out. But now that we've gotten this far, let's start cheating. Well, there's an internet, and of course, since there's an internet, the internet has already figured out all this. I apologize for the name, not my choice. Whoever pioneered some of these techniques named it that. It is fairly apt, and we're all just kind of playing in the sandbox here. So they give an example here of alert 1, but let's do alert hello world. And if we click encode, there it is, 18,511 characters for hello world. And if we select and deselect the eval source, you can see it changes the amount of characters we have to add in what makes it executable. Maybe you want it, maybe you don't. Maybe you just want to represent that as a string, or maybe you want to actually execute it. But let's go a little bit step further. Let's not just take their word for it. Let's copy this, and we're going to have to switch back to this tab because that's the one we have the console open for. We paste that in. Here it all is. And you'll note that for a decent while here, the syntax highlighting is still in place, and then it just kind of gives up. It just kind of dies because it gets so complicated. We go all the way down the bottom, make sure here, let's execute, and boom. Hello world in JavaScript using only 6 characters. Now, if that wasn't enough for you, and this is entirely true, you can also do this in PHP. There are a couple different tricks that you have to use, but PHP is another language where this will work. But you know what? Ah, shoot. I'm not set up to execute PHP, so we'll have to do that another time. But I will leave you with one of the standard notes on type coercion. Things like this, things like this. Oh, what did I do there? Invalid left-hand side argument. Let's try. Oh, I'm not sure what's going on there. Let's see. Things like this. This all works because of type coercion. If we use the triple equals, then we're actually making sure that the types are the same, instead of just that they can coerce into the same primitive. So be careful what you do out there. Wear your seatbelts. Be aware of type coercion, because it'll come back and get you. Normally at this point, I'd be happy to take a Q&A. I'm not sure how that's going to work, but if it does, I'll maybe see some of you in the Q&A. Otherwise, I just want to say thank you to the conference organizers for managing to put on a conference in this environment, inviting me to speak. I hope you guys have a great conference and hope to run into you sometime in the future. Thanks. Bye.